Look at another simple example of a one object problem, and that's lifting. So imagine that we have a big heavy box with some mass m, and we have a cable attached. Okay, so there's really only going to be two forces. We have the force of gravity going down, and we have a force of tension going up. Okay, so we'll look at a couple different cases. The first case is, what if we're moving this block with constant velocity, or or constant speed? So in that case, the net force is equal to 0, because if it's a constant velocity, this is also telling us that the acceleration is 0. So the net force is 0. And so if we look at the two forces, we have a force of tension and we have a force of gravity. And so this means that the force of tension is just equal to the force of gravity, right? This is no different than the statics problems that you solved in the last unit. But now we can say, well, what if we have, some acceleration? Okay, some acceleration, and a in the y direction. So now in this case, the net force will have no x component. We'll have a as our y component, but it's still equal to the same thing, right? When we sum our forces, we still have tension and minus gravity as our total force. So now we see that the acceleration is equal to f of t, with a mass here, of course. So the mass times acceleration is f of t minus mg, which means the force of tension is m times g plus a. Okay, so now let's see if this answer makes sense. First of all, we see that the units are correct. We have a mass times an acceleration for both terms. And so now let's see what this is saying. So this is saying if we are lifting up, then that means that that this force of tension is going to be greater than gravity. And that's what you would expect, because as you're lifting the block up, you have gravity acting against you, but you also have to apply a greater force to also accelerate it. So we should have something that's greater than gravity. But we can look at a third case. We can say that what if the acceleration is less than 0? Okay, so now we can write the force of tension. We can say this is m times g minus a, where we're defining a. We're defining a as positive, so that this is really kind of the magnitude of a. And so we have something that's a force of tension now that's going to be less than the force of gravity. And that's also what you would expect. We all know that if we've been carrying a heavy block and if we're putting it down, that's much easier to do than it is picking it up, because picking it up we have to apply a greater force, whereas when we're setting it down it's easier. And then notice a special, kind of a special case where we can say that the acceleration downward is equal to g, right? Because then this is telling us that our force of tension is 0, because we'll have a g minus g. And that again is what we'd expect, because that's basically a free fall, right? If the downward acceleration is 0, that means we're just letting it fall, so there's no tension in the wire. So we see that our answer makes sense in all three cases, whether we're accelerating up, if we're accelerating down, if we just have a constant velocity, or if we're accelerating g. The only other interesting case that we can look at real quick is, what if a is what if our acceleration is downward and the magnitude of a is greater than g, right? So now we have a net for tension that's less than 0. So what does that mean? Well, that just means that we're not actually, this wouldn't really work with a string, but this would work if we had something, a little bit more taut. And we could say, well, we're not pulling it now, we're actually pushing it, right? It's just saying that our tension would be down, because the only way to get this to accelerate faster than the speed of gravity is to have a force pushing down on it. So even in that situation, our answer makes sense. So this is all, every kind of lifting problem you have. It's just going to be, it's really just a simple one-dimensional motion problem. Is the force of tension bigger or smaller than the force of gravity? And that's telling you the direction that you're moving it in, and it's also telling you, how much, what direction your acceleration's in.